Okay, so the first problem that we'll be doing is from USACO 2019, and it's from the silver contest, and the name of the problem is grass planting. So let's first read what the problem statement is. So, all right, he wants to plant grass, and then there are n fields and n minus one bi-directional pathways. So immediately we could sort of think of like a graph algorithm here. And I can potentially plant a different type of grass in each field. Okay, he wants to minimize the number of grass types he uses. Maybe we could use binary search with some graph algorithm. And all right. Okay, so here we don't want the same type of grass planted in two adjacent fields or two nearly adjacent fields. So if I just draw that, so this is one point, and then this is another point, and this is another farm. So there's three farms, and if this has grass type 1, then this can't be 1. So this has to be 2. And if we ask if this can be 1, it can't because it's nearly adjacent. So it's connected to this. So it can't be 1, or it can't, nor it can't be 2. So this has to be 3. But if we come back here, I think this one can become 1, and then so on. All right, so we want to help him determine the minimum number of types of grass he needs for his entire farm. So let's see how we can approach this problem. We could use a DFS algorithm, but I sort of feel like that would be too complicated for this pretty simple problem. Um, let's see like what different cases we can have. So if it was like this, so this is n equals 4. Um, so if this form is 1, this form has to be 2, and this form can't be 1 or 2, so this has to be 3. And this can't be 1 or 3 or 2, so this has to be 4. Hmm. And we can draw a few more cases. How about something like this? So this is 1. This has to be 2. This is 3, 4. This has to be 5. 1. I think I sort of see a pattern developing here. So the answer for this one, let's use a different marker. The answer for this case is 3 because you need 3 types of grass. And then for this one, you need 4 types of grass. And then for this one, you need 5 types of grass. So if you see here, the maximum number of pathways a single farm is connected to, this one is 2. So for example, this farm is connected to this path and this path. And if you see here, the answer is 4. And the maximum number of farms that a farm is connected to is in this case this farm, and it's connected to 3 paths here, here, here. Also the same here, 4, and then one more, there's 5. And I'm not sure if there would be a exception case because for example, let's just say that this 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 because if any farm is more than 2 paths away, then it shouldn't really matter, right? What their colors are. So I think this algorithm makes sense. So we could like try to test this out because it just doesn't take a long time to code. So C++ compiler. Let's see if this will work. So sharp include input output stream include vector algorithm. Not sure if we'll need it. I'm using namespace standard int main. So what do we have to take in? So we have to take in n, and then n minus 1 line. All right. So int n, then n for int I is 0, I is n minus 1, I plus plus. And then let's try to make a graph. So I usually use a vector int and then an array of vectors. So how many? What's the largest size of n? 10 to 5. So 1, 2, 3, 4, 5. We can simply take in, so graph a dot pushback b, and we can do the same here, but instead of, we just swap the b and a like this, and we can look for the maximum. So now let's just, for safety, let's just say until this I plus plus, and then if graph I size, if this is larger than answer, we will see that answer is this. And then you just print out the answer. Then you have to make sure to add 1 to this. Let's see if it works for the sample test case. I think it should work. It should work for the sample test case because, oops, got a mistake here. All right, so this probably works pretty well. So how about we download this, right? And let's try to submit. Downloads. Oh, I forgot to write this in. Oops. I always forget this. Let's download this. Let's try to submit this. If it works. Oh my goodness. Try to clean this up. No, wait. No. Delete this. Just re-download this. Just like so. All right. So we've downloaded our code here, and I'm pretty sure that it will work. So let's submit to see if it's correct. What's wrong here? Oh, this always happens. I just forgot the semicolon. Ugh. Alright, so now it hopefully works. main C++. Submit. Okay, I think it worked. Yes. Right. So that's how I solved the problem. And let's see how the sample solution is. Not sure what it is. Oh, it's the same here. Yep, it's the same. Compute the degree of every node. All right, so I basically got the same answer as the solutions.